Alright, let's look at the section 8.3, problem number 7. Alright, so we want to set up an integral for the total hydrostatic force on this triangular region here. Alright, so let's do that. Alright, so first thing we're going to do is I'm going to put the x-axis and the y-axis at the convenient location. So I would probably put the x-axis right here and the y-axis right through the middle, so probably somewhere around here. Alright, so that's the y-axis. Alright, then I'm gonna pick a kind of a random location, so I'm gonna call here is y star, and I'm gonna draw a approximating rectangle at the yi star. So it's gonna look kind of like that. Alright, then let's find the pressure at level yi star. Alright, so pressure pi. Alright, and this is going to be just the weight density of water, which is delta, times the depth. I'm gonna call it the di. Alright, so di is simply just depth from here to there. So di. Alright, since this is an equilateral triangle, so this is 60 degrees here, 90 degrees, sorry, it says 30 degrees here, and this is 90 degrees here. So the ratio is 1, 2, and the square root of 3. So we know that here, at this point, this is square root of y equals square root of 3. Alright, so the distance, or I should say depth I, di, is just the difference between square root of 3 and yi star. So this is equal to square root of 3 minus yi star. Alright, so this is going to be, alright, so delta is 9800. And then you multiply by di, which is square root of 3 minus yi star. Alright, so that's the pressure at the level yi star. Alright, then we want to find the area of that approximating rectangle, so let's call it the AI. Alright, so you can see that, let's see, the width is going to be, as always, I'm going to use delta y. Right? Then we want to know the length from here to there. Right? So let's pull out the similar triangles. So I'm going to pull out the big equilateral triangle. Right? So like that, where base is 2, right? So it's so that's the original. So this is 2, right? Then height of this equilateral triangle is square root of 3. So you have a square root of 3 there, right? Then we look at this smaller triangle, right? So it's gonna probably look somewhat like this. Right, it's still equilateral triangle, right? Then this length is the one we want to find out, right? But we know the height of this triangle, right? So you have this is going to be yi star, right? So since these two are similar, because both of them are equilateral triangle, right? So the ratio of, for example, the question mark to, say, 2 has to be exactly equal to the height of the smaller triangle to the height of the larger triangle. Right? So if you want to find the question mark, we can just multiply both sides of it 2 to get the question mark is equal to 2 over square root of 3 yi I star. Alright, so if you want to find the area of the approximating triangle, it's just going to be base times height. So base is 2 over square root of 3 yi star, and the height is going to be delta y. Alright, then once you find pi and ai, we can find the force, hydrostatic force, just on that approximating rectangle. Right? So this is going to be simply pi times ai. Alright, so I'm going to put them together. Let's see, so we multiply these together. So I'm going to multiply 2 and 9800. So it's going to be, let's see, 19600. Then there's going to be square root of 3 on the denominator, so I put that there. And then you have a yi star. Then you have a quantity, square root of 3 minus yi star. Right? Then you have a delta y. Right? So once you have Fi, so we can actually find the hydrostatic force on the entire triangular piece. So this is going to be, right, we just go through the summation. So we have 1 to n. Then we just have to copy the same thing. Maybe I'll do that. So I'm going to just copy this, all right, and then paste it, all right. So I can just put it right there, all right. All right, then to make this approximation more accurate by taking a limit as n approaches infinity. All right, then we can just turn this into an integral. All right, so first I'm just going to put this constant in front. So 19,600 over square root of 3. Then limit sum always becomes an integral. All right. Then to cover the entire triangle, you have to go from 0 to square root of 3. Alright. Then you just strip off I and star. So you have a y times square root of 3 minus y. And delta y becomes dy. Alright. So this is the integral that represents the hydrostatic force on that triangular piece. All right, that's it. I hope that this was clear.